All right, so we've provided state to our React form for our insulin calculation, and now we're actually ready to do the math and calculate out the coverage amount and the correction amount. So I thought it would be a good demonstration of test-driven development if we went through that together and started with some tests that provided us with a meaningful sort of precondition and a postcondition, and then basically have that test drive the implementation of our tabulation. So let's dive in. What I've done here is I've already pre-filled two behaviors, and I've provided some data that's going to give us the ability to basically perform our calculation. So we have yet to declare this function, but basically what we want to do is write a function that's going to give me a correction value and a coverage value. Going back to the business logic, we're going to take the carbohydrates and divide them by the carbohydrate factor. And then we're going to take the blood sugar or the A1C reading, subtract the target blood sugar or the target A1C, and divide that by the correction factor. So this is our carb dosage, and this is our correction dosage. So I want our function to return both. What we're going to do to both values is we're going to truncate them to the nearest single decimal place. And I'll show you how to do that. And then what I'd like to do is conclude the function tabulation by doing some sort of rounding to provide a total recommended dosage. So that's what we're going to do here. So let's dive in and actually start implementing our math here. The first thing that I need to do is I need to design the sort of signature and the contract of this function, right? So I'm going to go ahead and I'm going to create a new file called calculate insulin. And I'm intentionally lowercasing that to indicate to other developers that what's going to be exported from this is a function. And I could kind of take and duplicate all these types, but I've already, in our form, in our previous episode, defined this type, right? So I want to reuse and repurpose this type. So what I'm going to do is I'm going to define in here in my models directory a calculation payload.ts. And I'm going to move these two types that I've created, or these two constants. Well, one is a constant, one is a type. We're going to move these into their own files so that other things like our function can use it, right? So we need to export these. We're going to need to import star z from Zod again, so we can infer our type. And then my form is going to be broken here, right? Because I took those things out. So what I need to do is add those imports. My form should be functioning just fine. And now what I can do is I can take my calculation payload type and pass it in here as a function. Okay, now in order to get my test to recognize that this is of the type calculation payload, what I must do is I must do z.parse. And that's going to tell Zod to basically take this raw JSON payload and form it into our schema, right? Actually, what we can do, we don't need the Zod import. What we can do instead is we can use the Zod object itself. I should be exporting that. Export calculation payload. Okay. So I should be able to do something like this. And there we go. And then we add our input for our function. We got to make sure we export that function. We do. So we can just manually add in our import here. And notice now what I'm getting is, hey, wait a minute, this thing doesn't return something that has a correction prop. So we're destructuring what comes back from this function and passing it in here. So TypeScript is telling us, hey, your return value for this function doesn't give me a correction prop. So we've got to address that. So we go back to our function. And to get our test to meaningfully advance, I could just say something like, and notice now that this test, I don't see any red squigglies, right? But I do know that I'm not going to get intended result, and that's okay. Let's get this test to a runnable state. We'll run the test, we'll watch it fail, and then we'll practice red-green-refactor to actually get this thing working. So we're going to do calculation payload. And we'll also return a coverage prop. All right. So now, this should be calculation payload, right? Now, my test is in a runnable state, so I can run over here and say, run my insulin calculator client test suite. And thanks to NX, my test suite's already configured with Vitest and ready to rock. Do we have a mismatch in our properties here? We might. Target A1C, correction factor, carbohydrate factor. I had misnamed my props. And then let's just double check A1C reading in our carbohydrates. Okay, so let's rerun the test. See, I got a bunch of messages about carbohydrate factor being expected, but I previously had this as carb factor, shortened it and abbreviated it. And generally, that's a good lesson, right? We try to avoid abbreviations in all of our naming so that it's less cognitive overload to remember how you kind of abbreviated something. So we always try to spell out words. All right, so let's run our test again. And you'll see we get a different type of error. We're not getting any type of exception. Instead, we're seeing that our expectation is not being matched, right? So correction is always going to return 0 based on the implementation of the function. And that's not going to match 0.3, which is the appropriate calculation for these inputs, right? So now we can do our math and actually tabulate our correction factor. So what we're going to do is we're going to say, okay, and what I could destructure the props that come in. So let's go ahead and do that. We're going to do, we'll let GitHub Copilot do its thing. We'll make this a little bit more readable. And what we can do is we can take these values and determine our correction. So the way that we're going to do our correction is we're going to take the A1C reading. We're going to minus the target A1C for the difference, where with a correction, you're trying to bring down the blood sugar level. So if the A1C reading is higher than the target, then we may have to administer insulin for a correction. And it's important to also have some logic in here. We should actually have a test for this that says it provides a correction amount of 0 if the A1C reading is less than the target A1C, right? So we can kind of adapt our own test for this. Take this payload. And what I'm going to do is I'm going to make my A1C reading less than my target A1C. So we'll do 130. But we're not going to worry about that for right now. We want to get this first test to pass, right? Red-green-refactor. I just wanted to add that behavior so I know it's an edge case that I need to handle for, right? So A1C reading minus target A1C divided by correction factor. And that's going to give us a value that could have more than one decimal place. So that's problematic. So we'll call this an unrounded. Well, no, we're going to do our rounding directly in here. So what we can do is we'll take this and we'll multiply it by 10. To give us a whole number so that I can round down. Math.floor is going to round down to the nearest integer. And then what I'm going to do is I'm going to divide by 10. I can actually just do that here. So we want to put that math.floor around the product there, right? So we're taking the difference of our A1C reading, our target A1C, we're dividing that by the correction factor, and then we're multiplying it by 10. And let's put parens around this as well, just to make sure that the math is super clear. Okay. So let's run our tests and see if we get a pass. So here we got one passed. So this is properly tabulating the correction factor or the correction dosage amount based on these tabulations. But notice I got a negative value here, right? I don't want a negative value. I want, in fact, my correction to be 0. So now I know I need to add some additional logic. So what I can do is I can say something like, let's see. And we can set our correction equal to the raw correction. And if the raw correction is less than 0, then we're going to make our correction equal to 0. So that should result in 2 passes. Two passed. Great. So now all that's left is for us to calculate our coverage amount for the carbohydrates that are going to be eaten. So what we're going to need to do here is we'll do a similar sort of math.floor operation, but it'll be a lot simpler. So we can just say const coverage equals math.floor. And all we have to do is take the carbohydrates in the carbohydrate factor and divide. So there we go. We've implemented our logic for correction and coverage. Again, hopefully we should get all green here. And we do. Now I might take a moment to just kind of see, all right, I've got passing tests now. Is there any way that I could potentially refactor this? Well, there's some duplication here what we could do is we could create kind of an internal function here, const round to nearest tenth, right? We take the value, which is going to be a number, and we say return exactly that. Thank you, GitHub Copilot, again. So now I can reduce that duplication and just pass in our tabulations, get rid of all this times 10 divided by 10 nonsense, right? And I like to really tighten up the feedback loop. So just to make sure that this function is behaving the way in which I expect, I'll just rerun my tests. You can also run these tests in watch mode so that when you're affecting changes in your editor, they'll automatically run. But for demonstration purposes, I thought it'd be useful to manually run these. So you can see I haven't caused a regression in the tests, so we're in really good shape. So now I can apply that same reduction of duplication over here and make sure our tests pass again. And there we go. So now what I want to be able to do is I want to basically be able to add those together and perform some rounding, right? So let's write a test to do exactly that. And let's just make sure that these numbers are all the same. They are. So I want to say it provides a recommended dosage. So I'm going to take all of this data. Oops. And I'm going to basically duplicate it down here. And what needs to happen is 1.6 plus 0.3 means 1.9. So I'm going to round up for that to be 2. All right. And we're going to say recommended dosage. And what do you notice? Well, we haven't yet defined what a recommended dosage is. So again, if we do the simplest thing that works, that advances the test, we can say something such as const recommended dosage. And we can do something naive like add those two values together. Now, it's good to have in mind, you know the test's going to fail, right? But what is the failure you expect? Well, we're not doing any rounding here. So we're going to expect that we got 2, but what we should get instead is 1.9. So let's just confirm that understanding by running the test. And we get a floating point 1.9, right? So this is pretty close. With JavaScript, we're dealing with a floating number, so it's going to be rather imprecise. We're going to make it precise. So what we need to do is we need to introduce some logic. And per our healthcare provider, the rounding logic isn't, if it's the typical math where if it's 1.75, you round up to 2. Basically, if it's between 1.3 and 1.7, you're going to round to the nearest half. And then normal rounding occurs after that. So we need to write some of that logic, ideally, in under normal circumstances. If I wasn't just going for brevity, I would have more test cases that would exercise rounding down, rounding to the nearest half, and rounding up. But we're just going to leave these test cases and perform our calculation. So const raw total equals correction plus coverage. And then we're going to define a let total, our recommended dosage. Right? And we say, okay, if what we want to do is if recommended we need to perform some math here, right? To basically grab the nearest whole number, right? Const nearest whole equals math.floor recommended dosage, right? And so now we have a decimal by taking the raw recommended dosage and subtracting the nearest whole. So this is going to give me a number 0.1, 0.2, 0.3, all the way up to 0.9, right? So if the decimal is less than 0.3, well, then we're going to round down. So we're going to return the nearest whole. So the recommended dosage is going to be the nearest whole. Else, if the decimal is less than or equal to 0.3, or the decimal is, greater than or equal to 0.3, and less than 0.7, we're going to make the recommended dosage to be nearest whole plus 0.5. And then else, we're going to just add 1 and round up. So let's see if that makes the test pass. Cannot access recommended dosage. So I need to define this let further up the call stack here. And we need to type it as well. Nearest whole. Math.floor raw recommended dosage. And then this is got to go down here. There we go. So again, the tests are telling me and giving me feedback on a discrete amount of business logic, which is incredibly helpful for working through this issue. So I think I might have this wrong. I think it's, if it's greater than 0.3 and less than or equal to, yeah, I think that's the actual math. Again, you'd want to check your business requirements, make sure you know clearly what your calculation is going to be. So we're dealing with 1.9. Recommendation near, if decimal, raw recommended dosage minus nearest whole. Recommended dosage equals nearest whole. Yep, oh yeah, I flipped this Boolean. I needed an and instead of an or. There we go. Now we're passing. So you can see already I messed up the logic twice, right? But my tests told me what I was doing wrong, right? And that continuous feedback that you get through test-driven development is what makes the practice so beneficial. You have to basically anticipate that as an engineer and just somebody typing keys into the keyboard, you're going to make logic mistakes, right? But if you have the power of tests helping you and serving as your backstop, you're less likely to make those mistakes. Or at least you'll have a signal that that mistake is apparent in the code. So right away, you see the power of test-driven development just watching me fumble through the implementation here. I hope that was helpful. In the next episode, what we'll do is we'll take these results and we'll actually display them on the page, and that will round out our application. See you next time.